Okay, our first topic of discussion, short topics, we'll just get to understand them as quickly as possible. Our first topic for today will be regular reflection versus diffuse reflection. Regular reflection, okay, and there is another term called diffuse reflection. I'm not writing diffuse right now. Let us first understand what is regular reflection all about. Okay, so let's see regular reflection. Let's say we have a reflective surface. Let's say we have a reflective surface. This is my reflective surface. Try to understand, then everything will be very clear. Let me draw it here. Let's say I have a reflective surface, and let's say a parallel beam of rays is incident on it. Parallel beam number one. Sorry, parallel a beam of parallel rays. Ray number 2 and ray number 3. Are they parallel? They're not parallel. Okay. So this one and say this one. 3 rays. Okay. And now let's see. Let's apply our law of reflection. So this is my first incident ray. This is my second incident ray. And this is my third incident ray. And let us try to put the laws of reflection out here. So what do? We draw normals at the point of incidence. This is one normal. This is another normal. And say this is the third normal. Okay. These 3 rays will get reflected. Now we will have what is known as angle of incidence. So let's say this is my I1, or I should say I, because they are all parallel. So this is I, and this is my I, and this is also I. So they get reflected back using the law of reflection, where the angle of reflection is always equal to the angle of incidence. So this is first one, the second one, and the third one. Okay. Try and absorb the concept first. If a beam of parallel rays is incident on a surface and the rays get reflected back also in a manner in which they are parallel to each other, such a reflection is known as regular reflection. Have you understood? Regular reflection means a beam of rays which is incident on a reflecting surface gets reflected back parallelly. Parallel aayega, parallel jayega. Okay? This is known as regular reflection. So let us understand what is the daily implication of this regular reflection. Now, what all are the surfaces which will show me regular reflection? So regular reflection will be shown by perfectly smooth or polished surfaces. So understand it better, with the best example will be your something like a plane mirror. The mirror in front of which you dress up, or the one which is in front of your wash basin. In this scenario, you will be exactly seeing your image. There will be no hindrance. Are you understanding? Like say the television when it is switched off. The television when it's switched off, you exactly see the reflection. So when a parallel beam of rays are incident on a reflective surface and they are reflected back again parallel, jaise aaye waise hi gaye, that is known as regular reflection. Now question comes, in our world, everyday world, do we experience regular reflection? Well, not. If everything was regular reflection, world would have been pathetic. It's just like you walking inside Bajaj Electronics with all the television switched off. So Nidhi walking, Nidhi, all Nidhis all across. So anytime you walk, it's like a mirror in front of you, right? So imagine yourself, had I made this glass tops using what? Tabletops using glass. And you put a table lamp out here. So जैसे आप लिखने जाओगे नीचे से और एक table lamp दिखेगा. You'll see your face. Will it be easy for you to write? No. And your copy will also start reflecting. So it will be a very, very weird thing. So this sort of thing is seen by perfectly smooth or polished, which is an example of which is our plane mirror or our dressing mirror. So question arises, what is the reflection then that is happening across all these walls and everything? We don't see our face. This is known as diffuse reflection. Diffused, and another word we use for it is known as irregular reflection. So what is irregular reflection? Okay. Irregular reflection, first I'm drawing a freehand drawing. It will save my time, but then I'll draw a perfect drawing. Okay. Again, a parallel rays have come and they have been incident on a reflective surface. They have been reflected on a reflective surface. They have been incident on a reflective surface. So this is your reflective surface. So here also we have a reflective surface. But in this scenario, what you will observe that the beams do not get reflected back parallelly. They're getting reflected back in this manner. So let's first understand it with definition. If a beam of parallel rays, when on being incident on a reflective surface, gets reflected as a beam of non-parallel rays, such a reflection is known as diffused reflection or irregular reflection. Okay, very easy. First thing that comes into our mind is, why did such a scenario happen? Do you mean to say, sir, in these cases we know laws of reflection are followed? In fact, in your school, in CBSE, this was wrongly taught. I will always be equal to R. So here you feel that I is not equal to R. That is the apparent feel that we get. But what we are forgetting, this is a law of reflection. A law is a law. A law will always be obeyed. The laws of reflection are obeyed here also. Then you should cross question me, sir, if the law of reflection is obeyed out here, then how do you say that the rays are not parallel to each other? Are you understanding the problem or not? Law of reflection is followed. मैं आपको अभी बता रहा हूँ, law यहाँ भी follow होता है. Sir, अगर law follow हो रहा है, then why are your rays like this? In your school it was taught in CBSE, then law is not followed here. Law is a law. Law will always be followed. In order to understand this, we will take up a small portion of this surface and we'll try to magnify and see what is happening. What is the story around here? This surface, which you are apparently seeing as smooth, like this tabletop, it's smooth for you, is not actually smooth from optics perspective. This surface is something like this. The surface that you are trying to see is not as smooth as you're watching. This surface is actually uneven. Like this. This is a microscopic view of a small portion of the surface. Now let us bring our parallel rays as we had brought, right? Our parallel rays were yellow in color. So let's have our yellow rays. So one yellow ray has come like this. The other parallel yellow ray has come like this. The third yellow ray has come like this. So are my incident rays parallel? My incident rays are parallel. No doubt about them. Okay. After that, what should I make? I should always make the normal at the point of incidence. Now, what do you mean by normal? Normal is always 90 degree with the point of incidence. So let's make some 90 degrees. So if I try to make a 90 degree out here, it's like this. If I try to make a 90 degree out here, it's like this. If I try to make a 90 degree out here, it's almost like this. Have you understood? Each angle of incidence is now different. In this case, each angle of incidence was same. And we will honor the law of reflection, which says whatever is the angle of reflection, whatever is my angle of incidence should be my angle of reflection. So let's honor it. This is the first reflected ray, second reflected ray, and third reflected ray. That's clear now. Parallel rays got reflected as non-parallel rays. Your apparent feel comes that this surface is not obeying the law of reflection. No, madam, the law is being obeyed because it's a law. You cannot disobey it. So what is so special about here? This surface is extremely smooth and polished, like that of your mirror. This surface is not that polished, and so I reserve my word and I'll call it that this is a rough surface. So all rough surfaces, rough not from the perspective of your feel, rough from the optics perspective. So if you are a rough surface, you will always support what? Irregular reflection. So now next question comes in our daily life. Clear? Irregular reflection. Okay. So irregular reflection also we have understood. Our next topic would be about plane mirrors. Okay. Anyways, I'll make a PDF of it and give it to you also. But that actually makes you go lazy. Plane mirror. So the pronunciation is not plain. It's not plain dosa. It's plane mirror. Plane means a plane. This is the book is a plane. This is a plane. This is a plane. So plane mirror. Something that is not curved. Something which is a rectangle piece of plane mirror. So a plane mirror we have already discussed in our last class that, what is the, how do you make a plane mirror? It's a glass sheet behind which you will have a reflective film like that of silver. The most costly the film, then the red oxide will be there. Today we'll see image characteristics. Image. Now this may differ a little bit from your book, but ये याद रहेगा तो सब कुछ याद रहेगा. Image characteristics of a plane mirror. So how to understand the plane mirror the best way? Well, it is the same mirror. Now bear with us, huh? Aliens watching us from some other planet will be saying, look at those morons. Their planet just completed one run on the sun and they are drinking and just celebrating it. Nothing, then the earth has just moved once around the sun. So from other planet, aliens will be saying, look at those morons. Their planet just moved once across the star and they are dancing like this. Anna? See. So let's see what is the image formation by a plane mirror. For us example, this is like your dressing mirror, let's say, right? And let's say this is our object. Kirtan is our object. Right? Kirtan is our object. So otherwise you'll not pay attention. Now he'll become very choosy. The first observation, whatever is the object distance, and our Kirtan is wearing a G-Shock, what do you call? G-Shock watch on his left wrist. Aha. He's wearing a G-Shock watch on his left wrist. Okay. So we need to make Kirtan on the other side also. So this is our Kirtan. So the first observation will be that the image distance is always equal to the object distance. If you are a plane mirror and you think yourself, when you dress up every day in front of the plane mirror, don't you see where you are standing? The other Ahiri is actually standing that much back. So you can come forward and actually meet fingers and again you can go back. Okay. So what is the first observation? Number one, image distance will always be equal to object distance. All these are being followed. Why? Because a plane mirror is honoring me regular reflection. Acha, what is the next one? The image height. The object height and the image height will be exactly same. Right? So our next observation will be object height is equal to image height. The third one, the image is virtual. Now what is virtual? I will come back to it a little bit later. Just next point of discussion. The image is virtual. Virtual का मतलब होता है this cannot be taken on screen. Cannot be taken on screen. When you watch yourself in the mirror, you can't take your image on a screen. You cannot take it on a screen. It is virtual. So you can't project this image on any screen. Screen means right now your shadow image is falling on this wall. This cannot be projected on any screen. You can only, if you go to play and literature and all, what do they show? When your conscience starts to talk to you in movies, what do they show? The conscience always appears in front of the mirror. Because that is something unreal. You can't touch it. That's what they are trying to portray. Na? So this is virtual. This image cannot be projected on a screen. It cannot take on a screen. But we'll discuss more about virtual images in the next section. So the first observation is that image distance is equal to object distance. Image height is equal to object height. And then the image is virtual. Third, fourth, the image is erect. Image is erect. You understand what is erect in optics? Erect and inverted. Inverted images can be seen if you go to science museums and all. They'll have some mirrors where you'll see yourself as ulta. That is called inverted. This is not inverted. This is an erect image. So in optics, we always discuss three things, children, about an image. What is the position of the image? What is the nature? Position and nature. When we say position, how far are you? When we say nature, you're going to say whether it is virtual or whether it is real, and whether it is erect or whether it is inverted. And a third thing also we say, what is the magnification? Do you understand what is magnification? Like when you go to a movie, you see Salman Khan this big. That's magnified. He's not that big. No? So what is your observation on a plane mirror's magnification? Same size. So when the magnification is same size, we say the magnification factor M is equal to 1. Right? Magnification is always expressed in two items. This one is a value and this one is a sign. If it is plus, it means erect. If it is minus, it means inverted. If it is equal to 1x, 1x zoom means same size, life size. Your iCard Ahiri is smaller than real Ahiri, yes or no? So your magnification will be less than 1 in your iCard. And tomorrow, if you are contesting elections in Telangana, then your image magnification will be greater than 1. But we will say, Ahiri is our next contestant. Her magnification is +3. +3 means the image of Ahiri that you are seeing is 3 times her real size, and plus means Sidha. It's not an inverted Ahiri. -3 means 3 times big. So what is your iCard? Your iCard is plus less than 1. Because in your iCard you are shown as Sidha, na? So it's plus and it's less than 1. In the case of plane mirror, our magnification will always be how much? 1. Image is direct, image is virtual, same size. So your magnification factor will always be +1. Means you are erect. Understood? Now here is where there's a problem with girls and ladies. Whenever they will dress up in sari or something, let's say, नहीं पता नहीं वो मैं ना उसके मिरर में मैं बड़ी मोटी दिखती हूँ. ऐसा नहीं है मैडम. ऑप्टिक्स के मतलब से तो सब कुछ सेम है. अगर आप मोटी हैं तो मोटी हैं. Or else you go and cross question that mirror. Don't you think this is a common observation? Many people say, when he clicks a photo, then in photo now I appear a little bit plumpy, but I'm not that plumpy. ऐसा कुछ नहीं है. Because laws of reflection tell you image height, object height same, image distance, object distance, and magnification is same. What another thing can happen, what I have not done is, I have not yet drawn the G-Shock watch of our friend Kirtan. Now Kirtan's G-Shock watch will now come here on his right hand. This is something that you will observe. Kirtan's G-Shock will be on right hand. Selfie invert ho jata hai na? So this is the most important thing. We say, this will be our point number, say 6. We say that the image is laterally inverted. In our days, we used to take time to understand, but in your world, you have got the camera and the selfie of your mobile, so you understand what is lateral inversion. Lateral inversion means normal sari wearing lady will appear as Gujarati sari wearing lady. Hai na?
Yeah.
If you take the palla on this side, then how do you see the image? Palla will be on this side. Pocket is side mein rehta hai, to image mein pocket this side. That's the reason that ambulance is written ulta on ambulance. Right. Not they can see. So it's like this. Right. So this is your car, and this is the ambulance which is tailgating you. You will be seeing it in your mirror. You are driving from here and you'll see here. So they write ambulance in laterally inverted way, so that when I am driving, I read ambulance as straight. So there are some questions like in English alphabets, there are some alphabets which do not make any difference whether you laterally invert them or not. A, O, H, I, V, W, M, they don't make any sense whether you invert it or you don't invert it. Have you understood? However, if you see an R, the R becomes a Russian R the moment you laterally invert it. So a question comes here, what is lateral inversion? The phenomenon due to which the image of an object appears laterally inverted is known as lateral inversion. That is, you have flipped the image on its horizontal basis. You flip it on the horizontal, that means you're flipping it on the vertical axis. Ye aisa ho jata hai. On the vertical axis, you're flipping it. Selfies of mobiles are said to be laterally inverted. And then you can again go and correct the image. That's how the mobile is processing it. The mobile first takes your selfie, means it will come. That's why this particular watch is on which hand? Left hand. It will appear as if he is wearing it on his right hand. So have you understood image formation by a plane mirror? Much more detail than your book I have taught you. A plane mirror will give you an image where the image distance is equal to the object distance, the image height is equal to the object height, the image magnification is same, 1:1. So if you're slim, you're slim. If you're not slim, you're not slim. Don't point fingers at that mirror and say, इसके इनके घर पे ना मैं थोड़ी सी मोटी दिखती हूँ, मैम आप मोटी है, simple बात. या आप पतली हैं, ऐसा. And otherwise the image is laterally inverted. Clear? Our next discussion should be virtual images and real images. So what all we have covered? Regular reflection, irregular reflection. Then we have covered about plane mirror, plane mirror and its images. Now we will, the properties of image I have done here. We'll cover about what is real and virtual image. Ready? Okay. Real. Real image, and then we have something called virtual image. Since you don't know ray diagram, there is nothing called ray in actual physics. Rays are a given concept to understand the geometry of optics. ऐसा थोड़ी है कि रे आता है वहां से. रे तो हमारा concept है. We have given this as a concept. As an arrow, where the head shows you where the light is traveling to, and the tail shows from where the light is traveling. Right? So, in order to form an image, any image, we need minimum 2 rays. We need minimum 2 rays, and these 2 rays should intersect. And the point where they intersect is actually the image formation. Have you understood? Now, this should intersect is very, very subjective. My rays can be like this. Rays are parallel. Will they ever intersect? No, they will never intersect. In this case, will we get an image? We will not get an image at all. इसमें आपको कोई image मिल ही नहीं सकता है. These are parallel rays. Parallel rays will not give you any image. Now the other way my rays can be such rays. Okay. This is called, keep an eye. This is called divergent rays. Divergent. They're diverging out. Okay? This is called divergent. नहीं समझते हो? This is called convergent rays. Now, which one will intersect? You tell me. Convergence will intersect, right? So, in the case of convergence, in this case, we will have actual. We'll have an actual meeting. You will have an actual meeting. Okay, right? And in this case, will we have a meeting? No, we won't have a meeting. So when the rays actually meet, the image that they will give out is known as a real image. Is this clear? So all the things, images which you see on screen or on a wall or some of the wall is also like a screen. They are all real images, right? A real image is formed by, and this real image can be an erect image. It can be an inverted image also. उसमें कोई issue नहीं है. The reals are always erect. No. A real image is formed by the actual meeting of 2 rays. Understood? Means the 2 rays should always be convergent in nature. ठीक है? And this image can be taken on screen. This image can be taken on screen. Clear? Now the question arises, ऐसे case में क्या होगा? What will be the case like this? So let me draw them separately out here. Our rays are in this nature. We'll leave a little bit early, don't worry. If you are curious, but थोड़ा समझ लेते हैं. So in this case, we don't expect that the rays will meet each other. So what we do, we extrapolate these rays. Extrapolate means कहीं तो meet करवाना पड़ेगा ना. So we bring them backwards. Which one? बोलो बोलो. Mahiri, don't hesitate. बोलो ना क्या है?
Okay, sorry.
Tell me.
No, the real image which can be taken on screen.
Real images can always be taken on screen. Virtuals cannot be taken on screen. Let us understand once again. If you have rays which are convergent in nature, they will meet. Point they will meet is where the image will be formed. Images which are formed by actual intersection of rays, actual, ये ray meet करेगा ही करेगा. That is known as a real image. Real image can be सीधा also or can be ulta also. That's a different thing. Don't understand. Don't take it with the English word real. That real means I should see it like myself. No. But as long as it is formed by the actual intersection of rays and it can be taken on a screen, such images can be projected on a screen. But you seeing yourself every day in front of the mirror is a virtual image, because the other Ahiri cannot be taken on any screen. You can't take it on any screen. Okay? Now we come back to virtual image. In the case of virtual image, the rays are divergent. ये तो आगे जाके मिलेगा ही नहीं ना. They are going to spread apart. But we want them to meet. So what we are doing now, we are trying to trace them backward. This is called extrapolation. And we extrapolate them backwards. And we do think that there is a meeting point, or we rather say that the rays emerged out from this point. So we'll get an image out here. However, this image is not formed by actual intersection of rays. You have done some sort of jugglery and you have made them meet. Such an image which will be formed will be known as a virtual image. This is a virtual image. A virtual image, usually we always see erect virtual images. So you'll get an erect virtual image. It can be big, it can be small, anything. Girls, you must be knowing, you have that beauty compact mirror. Have you seen the small one? That's not a plain mirror, huh?
No.
Why? Why it's not a plain mirror? Have you gone to a spec shop where you wear your specs is kept like this? That's also not a plain mirror, but that's where your concept of plain mirror should be clear. You feel that the plain mirror is, it's plain. No. Beauty compact mirror, you have understood. The mirror which is just behind the visor of the car. The car will also, that's called the vanity mirror. In bathrooms of hotel, right at the shower area, you'll have one mirror in which you can see the back of your head, like a zigzag, zigzag, zigzag. There will be a mirror. Back of your head you can see. So that mirror has got two sides. One side is actually a plain mirror. The other side is you can see the back of your head. So that is not a plain mirror. Even have you seen the dentist mirror? The dentist has got a small mirror which they will put in your mouth. So when you're using, so I'll explain with you girls. When you use your compact mirror, you're trying to either put a lipstick or something. At that time, that mirror is magnifying your image. आपको अपने मुंह से कोई मतलब नहीं है. You want to focus it on that area. The dentist is more interested to see only your tooth in an enlarged manner. Those are concave mirrors. They are bent, but that bending is not. It doesn't appear to you that they are bent, and you feel that it's a flat mirror. It's not a flat mirror. It's not a flat mirror. Put your face in front of that specs shop. They have got that mirror, na? How to try on that frame? Yeah. Can you see your collars and all every time? No. आपको सिर्फ अपना मुंह दिखाई देता है. No, it's a conversion. It's a concave mirror, but it is magnifying your what you call face. So it's not a plain mirror. A plain mirror can never magnify you. What is your size should be the same size that you see, irrespective of the size of the mirror. However, if you look at the car driving mirror, what does a car driving mirror do? Anyone, two on the side and one on the center. Now put your head together. That I have understood. Beauty compact mirror, the lips are seen bigger as you're putting your lipstick. How do you see a car mirror? वो तो तुम पढ़ रहे हो, उसमें लिखा रहता है objects appear closer than they are. वो नहीं, आप दिमाग नहीं लगा रहे हो. Why is the car mirror given to you? To see a cow or a car or a buffalo behind you. Do you see the buffalo on the car mirror? When the buffalo is behind you, obviously. How do you see the buffalo? You see the full buffalo behind you? 4 or 5 buffaloes. Why not? You see 4 or 5 buffaloes. Is the buffalo that size only? That's a convex mirror. There the images are smaller. There, if you have put your lipstick mirror, then you will see only brown eye coming behind your car. Just put your common sense now. If you put your lipstick wala mirror, that concave mirror as your rear view mirror, our friend Ahiri will say, no, some brown thing is there. That brown thing is only the ear of the buffalo. That is a convex mirror. Convex mirror, our job is, what is our intention? To have a wide angle view. You want to see everything that is happening behind your car. So trucks, पूरा truck दिखता है कि नहीं तुम्हें तुम्हारे mirror में? Truck, how big do you see the truck? This much. Is the truck this much in size? No. So a convex mirror will always make size of the images smaller. Concave mirror makes the size of the images bigger. Plain mirror retains to where you are. So if you see that there is some mirror which has been sold to you as your wash basin mirror or dressing mirror, but when you stand in front of it, तो छोटा छोटा height लगता है, so it's not a good quality plane mirror. It has some convex appearance in it. Convex होने से ही आप छोटा हो जाओगे. This many people in job interviews also answer wrong. They are not able to appreciate the fact that the herd of cows, which may have 3 or 4 cows, you see all the cows behind you on that mirror. But are the cows of those size? No. Okay. Have you understood between real and virtual? So real images are formed by the actual intersection of rays. Such an image can be taken on screen, and such an image can be erect and can be inverted also. Virtual images are always formed when rays are extrapolated, and you try to bring them backwards, because in actual the rays are convergent, they will never meet. Okay. So real and virtual properties of image. Okay, how many of you know what is a kaleidoscope? Design. So what is the idea of a kaleidoscope? A kaleidoscope actually has 3 similar rectangular pieces of mirror, 3 mirrors of this type. 1 mirror, other mirror, and 3, all held up in such a way that it makes an equilateral triangle. And then what they do, they keep some broken pieces of bangles on this side. So you will see multiple reflections. In fact, in villages and all, if you still go, then mele mein ye khub bikta hai as a kaleidoscope, and then they'll put some broken bangles out here, and then put some transparent things. So when you try to see it, you see a whole world of what is called colorful images. That actually concludes your reflection part of the unit, and we come to refraction. So refraction we have spoken earlier. We have one more thing to discuss here. We'll discuss 2 topics, real depth and apparent depth, and we will also discuss about critical angle. Do you remember, because a lot of you people have been absent in those classes, refraction. Refraction is the bending of light as it enters from one medium to another medium. So let's do some revision. When light rays enter from rarer to denser medium, the speed of the light falls and the light ray will bend. And it bends where? It bends towards the normal. You need a support. And when the light is going from denser to rarer, when the child is getting out of the bus away from the normal, it gains energy and the speed of the light increases. So bending of light which happens at the interface due to a change in speed of the light is known as refraction of light. So in refraction of light, let us see some common examples or aspects that we see. Ajay, have you seen that when you go into a swimming pool, all of you must have gone, the swimming pool actually appears to be of less depth. The first step that somebody takes on the swimming pool is very nice. If you're in the swimming pool, you watch somebody who is coming in, he will think that the depth of the swimming pool is very less and immediately puts his leg and feels that the swimming pool is actually quite deeper than what it is. So there comes a concept of apparent depth and actual depth. So if I'm a new person who's trying to go into the swimming pool, I feel that the apparent depth of the swimming pool is less, but actually swimming pool bahut zyada deep hai. So let's see how that thing happens by a diagram, then you will be able to appreciate it. So let's take up, let's say, or let's bring the diagram here. So let's say this is a tank or a swimming pool of this much depth, right? And the swimming pool is filled up with water. So we have water till this much. Okay, only 2 lines I have drawn, which shows that this much is the depth. Okay. So let's see why the swimming pool appears to be of less depth. This is water, this is air. Which is more denser? Water is more dense. Air is the rarest of all. So let's pick up a point. Let's say this is the point which I am trying to observe. So there is a ray which is coming out from this particular place. Okay. So this is my ray which is coming and hitting the surface. Are we fine? Now at this surface, once it has hit, I should make the normal at this point of incidence. So this is the normal. Clear? There is another ray which is coming out, same from this surface. Okay. Sorry. So there is ray number 2, right? Both of them are now incident. Now this top dotted layer is actually the interface. On top side it is air, and on bottom side it is water. So let me write those also. So you have H2O on this side, you have air on this side, which means this is a rarer medium, this is a denser medium. these are the two rays which have come out, and this is P, which is the showing the actual depth. And what is my actual depth? This is my actual depth. Have we understood? And there are 2 points of incidence. So what I'm trying to draw are 2 normals at the 2 points of incidence. Okay. So this is one more normal. Okay. What do you expect now? Light is going from denser to rarer. So what should the light do? Bind away from the normal. Okay. So let's say it bends away from the normal. This ray has bent like this, and this ray has bent like this. Both the rays have bent. Kya ho gaya? Now phone, I know that, but why are you laughing? You've silenced it, right? You want to take the call? Are we fine? Now come to your concept. What type of rays these are, Kirtan? Divergent rays. Do you expect them to meet anywhere? No. But we need to get an image. So what is the phenomenon we'll use here? Extrapolate them backwards. So let's say, itna kya hansi aata hai? Ek ring baja hai. Come on, people yaar. I mean, you people are like, man, God help you here. So we extrapolate them backwards. Are we fine? Right. And we get a point of intersection. Let's say, okay, this is my point of intersection. This is nothing but the depth of the pull that our friend Kirtan is watching when he's watching it from outside. Did you get it? So this is the actual depth. And what is the apparent depth that you are feeling? This one. Apparent. हाँ, virtually है ना, ये सही में ऐसा हो सकता है क्या swimming pool? So another example of it can be a coin dropped in a tank appears to be raised. Right? Another example can be a pencil dipped into the water appears to be like broken. क्या हो गया? इतना क्यों हंस रहे हो? कुछ रिलैक्स नहीं कर रहे हो, तुम्हें हंसी आ रहा है, तुम हंसी रहे हो. एक फोन बजने से ये हाल है. Good that I have never taught you all biology or something like that. Otherwise, whole class you'll A meme is understood. So much of laugh. So you want to see how a stick appears to be bent. So let's now you'll see everything as yes, sir. So let's see how does a stick appear to be bent. Okay. These are all the effect of, we call them as effect of refraction in our daily life. So you have got water out here. ठीक है, रोक देंगे आज. तुम लोग यार इतने हंसते. हाँ, we'll do a tour of the apartment. Why not? खत्म करते हैं ना. Another, let's finish this and then I'll tour you the whole apartment. Don't worry. Right. So we have a stick. So let's say a pencil has been dipped into this. So this is the pencil. This is the pencil which is actually dipped. Right? Or let's say you have dipped it straight. This is the pencil which you have dipped. Understood? Okay. Now let's take two light rays from the tip of the pencil. Light ray number 1 and light ray number 2. Or let's make them like this. Two light rays. So two light rays go and meet at 2 points. So we should have two normals. One normal out here and one normal out here. So you're going out from where? Again, Kirtan, water to air, denser to rarer. So you should bend away from the normal. So let us make them bend away. So, right, let's bend them away. So this one bends further away. This bends further away. Will they ever meet? No, they will not meet. So our only way to make them meet is by extrapolating them. Does it spend too much? Right, 1 minute. Okay. So let's say this one, sorry, this one has bent like this, and then we extrapolate them. They've met here, right? This is the tip of the pencil that you will be actually observing. So the pencil appears to you bent in this side. Where are you watching the pencil from? Watching the pencil from here. So a pencil, so I'm now mutating the diagram. A pencil which is actually straight, you observe the pencil like this.